Let's look at function compositions. Function compositions are basically taking one function and putting it into another function. And this little circle right here does not mean multiplication. It actually means composition or compose. So if we do f of g of x, we're going to write it as f of g of x with these parentheses, okay? And that substitutes the g function into the f function. And then if we have g of f of x, we do the reverse. Let's walk through a problem and see how this works with actual functions. So our f of x function is going to be 2x plus 4, and our g of x function is 3x minus 5. And this says find f of g of x. Okay, so we can rewrite this as f of g of x with parentheses. And notice that inside we have our g of x function. So I want to relate this back to something you've already done. If I had f of 2, what does that tell me to do? It says our x value is 2, and that says take 2 and put it in place of x in the f of x function. Well, now instead of 2 being there, we've got g of x being there. So this is essentially f of g of x. Well, what is g of x? G of x is 3x minus 5. Okay? There we go. Okay, what does this tell us to do? Well, just in the same way that 2 says plug in, this says plug in as well. But we're plugging in 3x minus 5 into the f function. So what is f? F is 2x plus 4. We're going to write that, but wherever the x is, we're going to put parentheses. So this would be 2 parentheses plus 4. And then what goes inside there? Well, it's whatever you're plugging in. And in this case, we're plugging in the g function, which is 3x minus 5. So this will be 3x minus 5 here. And then we're going to distribute. Okay, so we're just simplifying here. We're not solving anything. 2 times 3x is 6x, and 2 times negative 5 is negative 10, plus 4. And we want to simplify this. So we're going to combine those two like terms and get 6x minus 6. So again, if I'm looking at this function notation, this composition notation, I'm saying from left to right, start with the f function, that's 2x plus 4, write it with parentheses, plug in the g function, which was 3x minus 5. Okay, so that's what we're looking at. Now, let's look at our other example. This is the reverse. So from left to right, what function are we starting with? We're starting with our g function. And our g function is 3x minus 5. So we're going to plug in something here into the place of x. So we're going to write this as 3x, but now it's parentheses, minus 5. Don't forget to bring down that minus 5. A lot of students do that. Now, what are we plugging in? We're plugging in the second function in this list. So g we already have, and we're going to plug in f of x, into the function g. So our f of x is 2x plus 4. That's going to go in here. Okay, so now distribute. That's going to be 6x plus 12 minus 5. And adding like terms, we get 6x plus 7. So this is still substituting. It's just substituting another function instead of just another number or a number. All right, let's look at our next two because it's going to use what we've already done. So this is saying, let's see if I can get down to the answer. There we go. This is saying f of g of negative 2. What this means is first, find or figure out f of g of x, then plug in whatever you have for x, which in this case is negative 2. So do we have a f of g of x? Yes, we've already done that. We did that here and we got 6x minus 6. And now all we're doing is plugging in the x value that it's giving us. So we're going to say 6 times negative 2 minus 6. And then simplifying this, this gives me negative 12 minus 6, and that's just negative 18. Okay, so if you plug in an x, you get out an x. If you plug in a number, you get out a number. Looking at our other example here, this basically is saying, first, find g of f of x, then plug in 3. All right, so g of f of x is going to be the 6x plus 7, and then we're going to plug in 3. So 6 times 3 plus 7 is 18 plus 7, which gives me 25. I want to make a quick note real quick too. This function notation, f of g of x, this x part, same thing here, this x part, none of those mean multiply by x. This is the same thing as just writing f of x, and that just means the function f with the variable x. And that's what this means as well. So don't multiply by x. I see some students try to do that. That does not mean multiply. This is just, again, function notation. Okay, let's look at one more or a couple more examples with more complicated functions here. Okay, so now we've got f of x equals 3x squared minus 2, and then we have g of x is 2x plus 5. And this wants us to find f of g of x. So again, we're going from left to right. We're going to start off with f. F is 3x squared minus 2. Now when we write this, again, we're putting parentheses around the x, and that square is going to go outside that parentheses. So this is going to be 3 parentheses squared minus 2. What goes inside here? It's going to be the g of x. So the 2x plus 5 goes inside. Okay, now simplifying this, we have to remember that when you have something squared, you write it twice. A quick example of this is if I have y squared, that's y times y. Okay, so don't distribute the 2, like backwards distribute the 2, the squared. Don't do that, okay, because it's not going to give you the right thing. What you do have to do is write it twice so that we can FOIL this out or do double distribution, however you want to do this. So this will be 3 times 2x plus 5 and then another times 2x plus 5 minus 2. Now, the next step that I would do is leave this 3 as it is. So we're just going to bring it down. And let's do this multiplication through here. I'm going to use FOIL method, but you absolutely can use double distribution. So this will be 2x times 2x. That's 4x squared. Outer is going to be outside 2x times outside 5. So 2x times 5 is going to be 10x. Inner, 5 times 2x is another 10x. These should be the same if you are doing this correctly. And then 5 times 5 gives me 25. And then we're going to bring down the minus 2. Okay, I think we probably need to clean this up before we go too much further. So let's add these two terms together on the inside. That will be 3 times 4x squared plus 20x plus 25 minus 2. Now we can distribute the 3. So that's going to be 12x squared plus 60x plus 75 minus 2. And now we can finally do the minus 2. So this would be 12x squared plus 60x plus 73. So that's a lot of steps, but you should definitely know how to do this one because this comes up a lot. And again, I don't want you to stop here. You need to remember that this part right here gets written twice. Okay, actually technically this part gets written twice because of the square. Okay, I do sometimes see people not doing that correctly, so make sure you practice how to do that. And then our other side is the reverse, so g of f of x. So we're going to start out with g this time. G is 2x plus 5, so this will be 2 parentheses plus 5. And inside of that, we're putting f. So f is 3x squared minus 2. Now, because there's no square right there, we do not have to write this twice, and we are good to just distribute. So this will be 6x squared minus 4 plus 5, and that is just 6x squared plus 1. So obviously that one's the easier side. We like that one better. But you got to know how to do both. Definitely know how to do both with these types of problems, with one being a quadratic and one being linear. Okay? Practice those compositions.